Good morning, boys and girls, and welcome back to the southern wing of the Stink Bug Works. I really don't have a whole lot to show you today that's new. I'm mainly here because tomorrow, what is tomorrow? Tomorrow is Wednesday, and then Thursday, the following day, I'm going to be out in Highland Valley doing perk tests. Now, it may only be Wednesday. I have a sneaking suspicion these are going to be real fast test holes, and the fast ones can be done in a day. The slow ones take 2 days. So, before I just leave you high and dry, since I'm going to be out for a few days, I thought I'd talk about why I'm going to gear this motor. And here's why I'm going to put that motor on the gearbox. According to the calculations I ran through FE Calc, back when I had FE Calc, this motor would achieve maximum efficiency at a certain RPM, and that RPM had me spinning a real small prop. The problem with a really small prop is on a boat like this, it's just going to cavitate. So let's look at what we have here. If we have a graph that shows efficiency and RPM, it's going to look kind of like this. And then at the end, there's an explosion. So, to operate at your, and this is for a given voltage. Let's just say it's running 3 fully charged LiPo cells with a voltage sag, because of the current it's drawing. Let's just say each cell is putting out 4 volts, so this would be 12 volts. So this is the efficiency chart at 12 volts. Well, you want to be up here at the maximum efficiency, but that means your RPM has to be up here pretty high. So to get your maximum efficiency from Steve's Motors, let's talk about that for just a second. Steve spends all his time and effort to obtain maximum efficiency on his motors. Because if your motor's the maximum efficient it can be, then you're getting the most power out of it. Let's just say you're down here. Well, you have the same voltage, it's still the same 12 volts, but your RPM is lower and your efficiency is lower. Well, what's happening to that same wattage you're putting in there? It's going out into heat. So the more efficient a motor is, that means more electrons are going into making the thing turn as opposed to making the thing hot. So if you got less of the electrons making it hot, you've got more to spin the propeller. So maximum efficiency is what you really want in a motor. That's the key thing, is how efficient is the motor. Then once you know that at this RPM here, that's your maximum efficiency, then you kind of have to reverse engineer a propeller or a drive system or whatever. So the secret is you want a setup that runs your motor at this RPM. And that setup is going to be based on the prop. Now, if I went direct drive with this motor right here at this, I'd have to turn a 427. And a 427 is kind of tiny for this boat. It would get stupid speeds on 2S, but a 427's kind of tiny. So now in today's world, you just buy a motor with a different KV so that this efficiency point is at the prop you want. Well, I don't have that motor. I have this motor. And this motor, this efficiency, I've got to have a 427 here. Well, if I gear it down, now follow me, I can gear it down to where it appears the motor has a different KV, because this propeller sees the revolutions of the prop shaft, not the revolutions of the motor. So if there's a gearbox in there, then it essentially changes the KV and the KT, the torque constant of the motor. It basically, the KV and KT are going to be inversely proportional. So as one goes up, the other's going to go down. So that's the point of running a gearbox, so I can spin a bigger prop. So then I will actually have to experiment with bigger props to find out what is the right size. In the direct drive that I was initially thinking, I had to use 1/8 inch props, because a 427 would have been a 90 amp prop. So by gearing it down, I can get the RPM up to where the motor's operating in an efficient band. So that's my plan for that. Now, how am I going to do that? And here's what I'm thinking. I'm thinking I'm going to have the motor here. So I got the motor here, right? It's a little box like that. It's got a shaft. So I'm going to have the motor there, and I'm thinking I'll mount it on a plate with 2 mounting screws, and one of the screw holes will have a smile cut that you can rotate the motor through that smile. And the idea of that is to be able to adjust your gear lash. And then, just like that other little drive that I showed you the other day, this plate that serves as a motor mount is also going to mount a carbon fiber tube. And that carbon fiber tube will hold a couple of ball bearings. Then I'll put a gear here on the motor shaft, and a gear here on this shaft. And I plan to use 5mm shafts throughout. So I'll have a 5mm shaft coming out there. And that will be my output. And that's how I plan to mount it, or at least to make it. We'll talk about how I plan to mount it at a later date. Until then, boys and girls, jet out.